Chapter 1, Section 1. OSHA has called falls one of the fatal four. In 2012, falls killed 279 out of 806 fatalities in the American construction industry. In Canada, falls are the leading cause of accidental death in the workplace. Outside of occupational settings, the Canadian Centre for Injury Control and Research has claimed that falls are the leading cause of injury admissions to the hospital. Simply put, falls at work and at home are the leading cause of injuries that harm and kill. Case studies. Case study 1. A worker was ascending a fixed ladder in a concrete water treatment tank. As the worker climbed, he held 2 wrenches in his hand. The wrenches made it difficult for him to grip the ladder. At approximately 4 meters or 12 feet off the ground, the worker lost his grip and fell. He later died in hospital from a head injury. What could this worker have changed to prevent his fall? Answer: light tools can be secured to an appropriate harness, and heavier equipment and tools should be brought up with a rope. Case study 2. An electrician was laying cables into a cable tray. While working, he had to climb a ladder to access his work area. He then had to reach out over a handrail that was preventing a fall from the second to the first floor. During work, the electrician lost his balance and fell onto the handrail. He then toppled over it and fell to the ground 4.3 meters or 14 feet to the ground. What could this worker have changed to prevent the fall? Answer: the worker should have been tied off using fall arrest equipment to stop his fall to the lower level. Alternatively, a job like this could have scaffolding constructed to allow the workers to work more safely. Case study 3. A group of iron workers was assembling a prefabricated metal building. They had completed the skeletal structure and were covering the roof with insulation and metal cladding. They had attached fall protection equipment to be used. The foreman was on the roof talking to the workers, not using the fall protection system in place. As he finished talking, he began to walk away backwards. Forgetting that he was standing near the edge, the foreman simply walked off the edge and fell to the ground 20 meters or 65 feet below. What could this worker have changed to prevent his fall? Answer: the foreman should have been tied off with fall protection equipment available. Section 2. Fall forces and speeds. During our lives, we experience a variety of falls. We will slip, trip, and fall down in a variety of situations at work, play, and home. One concept we are intrinsically aware of is that the further you fall, the faster you go, and the more it is going to hurt when you stop. Additionally, we know that while what we land on is important for our fall to be safely stopped, a slow deceleration is equally important in reducing our stopping force or maximum arrest force. The maximum arrest force is the short duration stopping force. Almost everyone has taken a short 4-foot or 1.2 meter fall off of a diving board, easily generating enough force to cause serious injury or even die. What prevented the consequence of this fall is that while one was jumping off a diving board, they fell into the water, which slowly decelerated one's fall. Another fact we are all aware of is that falls can happen suddenly. Most people can imagine a time when they were walking across an icy surface and the next thing they knew, they were lying flat on their back. Watch this experiment we conducted that demonstrates a worker's ability to grab hold of a structure and stop them in the event of a fall. Gravity influences our body to quickly accelerate and generates enough force that our reflexes and strength are not able to react and stop the fall. The typical time reaction of a human is approximately 0.3 to half a second. In this amount of time, you will have already fallen about 1 meter or 3 feet. Review the chart of typical fall times and speeds. The lesson of this section is that we do not have quick enough reflexes to prevent ourselves from falling. We also saw that one's speed accelerates exponentially during a fall. Case study. Flight Sergeant Nicholas Stephen Alcamad, 1923 to 1987, was a tail gunner for a Royal Air Force Avro Lancaster bombing during World War II, who survived a fall of 18,000 feet or 5,500 meters without a parachute after his plane was shot down over Germany. On March 24, 1944, the 21-year-old Alcemad was flying to the east of Schmallenberg, Germany. He was returning from a bomber raid on Berlin when his aircraft was attacked by a German fighter plane. Alcemad's plane caught fire and began to spiral out of control. Because his parachute was destroyed by the fire, Alcemad opted to jump from the aircraft without one, preferring his death to be quick. He fell 18,000 feet or 5,500 meters to the ground below. His fall was broken by pine trees and a soft snow cover on the ground. He was able to move his arms and legs and suffered only a sprained leg. The Lancaster crashed in flames and the other members of the crew did not survive. He was subsequently captured and interviewed by the Gestapo, who were initially suspicious of his claim to have fallen without a parachute until the wreckage of the aircraft was examined. He was then a celebrated prisoner of war before being repatriated in May 1945. Compare this to a recent story about a newspaper delivery worker who was walking across an icy parking lot, slipped on some ice, fell backwards, and was found dead a short time later due to his head injury. The lesson of this scenario is that while acceleration increases relative to the distance of the fall, its forces are also determined by the deceleration distance when force is applied to the body. The outcome of the fall is not entirely dependent on the distance. Section 3. Types of falls. In this section, we will review common scenarios that are involved in falls. We will discuss slips and trips, falling to a lower level, falling from a ladder, and falling on stairs. Slips and trips. Put down sand or salt on slippery surfaces. Ensure your footwear is in good condition and properly tied up. Walk and don't run. Pay attention to your surroundings. Housekeeping. Keep your work areas tidy. Falls to a lower level. Cover holes and openings to lower levels. Use fall arrest equipment. Use a man lift or scaffold to access a work area when possible. Use travel restraint systems if you are on flat top roofs. Falls from ladders. Keep 3 points of contact. Don't climb with tools in your hands. Use fall arrest systems on ladders that are equipped. Tie off to an independent fall arrest system if you have to work from a ladder. Falling on stairs. Don't place items on the stairs. Walk. Do not run on stairs. Make sure cords and cables are not placed on the stairs. Ensure temporary stairs are properly stabilized and sloped at the correct angle. Section 4. Safety legislation. Each jurisdiction creates rules for workers and employers at a worksite. The legislation refers to both general requirements of all parties on the worksite and also to specific requirements of fall protection. You are responsible to know the legislation for your province or state. Not knowing the law is not an excuse to break it. Most jurisdictions require that each employer does everything reasonably practical to ensure the safety of employees on a worksite. There are several ways to measure what is reasonably practical. However, some of the tests used are: 1. A comparison of your company and its peers. What are other companies in your industry doing to address specific safety concerns? Is your employer a leader or following in the industry? 2. How feasible is it to implement the safety control? If the solution is in the budget for cost and time, then it should be implemented. If the control is not possible because of the massive cost in dollars and time, it may not be reasonably practical. This is a simplified explanation of general safety legislation requirements. There may be differences in your jurisdiction. It is also important to consider who the employer is. Corporations and organizations are legal entities. However, they are not actual persons. That means that a corporation or organization is operated by the people who work there. This means that those who make decisions in the organizations act on behalf of the entity. Executives, managers, foremen, and even workers can be classified as employers in some cases. Even a low-ranking worker in a company can be responsible as the employer in some cases. Workers also have responsibilities. They are required to ensure that they follow all of the rules and procedures required by their employer. They have to ensure that they are working safely and that their actions do not injure someone else or create an unsafe situation. In response to injuries and fatalities, provinces and states have been increasing the legislation around fall protection for workers. They are trying to send a message to employers and employees that they need to work carefully. The costs associated with injuries and fatalities are too high. Negligent individuals have faced criminal prosecution, jail time, and fines in the $100,000 to $1 million range. There is also specifically written legislation. In legislation, the following points are generally defined. 1. At what height is fall protection required? 2. What standard-setting body must approve the equipment that is being used for fall protection? 3. What are the anchor strength requirements for permanent and temporary anchors? 4. What situations require anchors to be certified by a professional engineer? 5. What documentation must be in place before work begins at height? Typical examples include fall protection plans and fall rescue plans. 6. Training requirements for workers who use fall protection equipment. 7. Training and equipment requirements for rescuers. 8. How much clearance and free fall is possible. 9. What the maximum arresting force for workers is. 10. Compatibility requirements for using fall protection components together. The requirements in your specific province or state may vary. Make sure you understand the law. Trained versus competent. This training course you are currently taking will make you trained in end-user industrial fall protection. Unfortunately, this does not mean you are competent. Your employer has work to do to ensure you are competent to work at height. Competency is a combination of training and experience. You are classified as competent when you can safely do the job with little or no supervision. Section 5. Fall protection definitions. This section discusses the specific terminology that will help you understand how to use fall protection equipment. Active fall protection systems. Active fall protection systems include harnesses, connectors, and anchors, and require a worker to take action to set the system up. Systems such as fall arrest and travel restraint that require a worker to properly select, inspect, and don a harness and attach a lanyard. Because humans are fallible, users can make mistakes and suffer the consequences. Passive fall protection. Passive fall protection systems are equipment such as safety nets and handrails. These require no worker involvement. Workers are protected without having to take action to connect to a fall protection system. Primary fall protection. This is the system supporting the worker's body weight at height and can consist of feet, bosun's chair, and positioning lanyards. The most common systems used are hands and feet. Secondary fall protection. This system should never support the worker's body weight under normal use. It will only support weight if the worker falls. This system may consist of lanyards, self-retracting lifelines, cable systems, fall arresters, etc. Fall arrest system. This consists of a harness, an anchor, and a connector such as a lanyard with an energy absorber. A fall arrest system will permit you to fall, but will decelerate to stop the fall once it has begun. Travel restraint system. A travel restraint system often comprises of a harness, lanyard, and anchor. These limit your ability to travel to an unguarded edge. A travel restraint system stops a fall before it can begin. Work positioning system. A work positioning system can be used to stabilize a worker at height and can replace positioning the body using the hands or the feet. As a work positioning system supports your body weight, it must have a backup, a fall arrest system. Control zones. The use of a control zone is an approach to fall protection that places special requirements on workers and work being performed on nearly every level working surface within 2 meters of an unguarded edge from which a worker could fall. Control zones can be used on surfaces having a slope of up to 4 degrees measured from the horizontal. Safety nets. Large specialized nets are suspended below the work area ready to catch workers in the event of a fall, commonly used in bridge repair. Fall arrest systems. Definition and design purpose. A fall arrest system is designed to protect a worker who is exposed to a fall to below. The system will permit a worker to fall. However, it is designed to stop the fall after the fall has begun. Typically, an energy absorber is incorporated into the system to safely decelerate the worker. A fall arrest system will contain an anchor, body harness, connector such as a lanyard, and a rescue in the event the worker falls. Limitations. 1. Typically, an energy absorber will be incorporated to minimize arresting forces. These systems require a sufficient anchor point to be located high enough. Fall arrest is classified as a secondary fall arrest system. Uses. 2. Fall arrest systems are commonly used on skeleton structures. However, they have a wide variety of uses. Anytime a worker is above 3 meters or 10 feet and a fall is possible, a fall arrest system can be used. Types. 3. Fall arrest systems use the various types of connecting devices. For example, fall arresters and life safety ropes, self-retracting devices, horizontal lifelines, and lanyards. There are a variety of configurations of lanyard that can be used. Single leg lanyards, double leg lanyards, lanyards with small snap hook connectors, large snap hook connectors, carabiners, tie-back lanyards, adjustable lanyards. Lanyards can be constructed of wire, rope, and webbing. Compatibility. 4. Ensure the components connect to each other in a safe manner. For example, never connect 2 snap hooks to one another, as they may bind and break the gates of one connector. Fit. 5. According to hierarchy of hazard controls, this is a PPE option, therefore used as a last resort. Hazards. 6. Fall arrest systems include the risks of excessive freefall, large arresting forces, and swing falls. The most important step in minimizing these hazards is proper setup of the system. Anchor the lanyard directly above you and keep it at shoulder height or higher. 7. Never attach another worker to your harness. Travel restraint systems. Definition and design purpose. A travel restraint system is designed to protect a worker who is exposed to a fall off an edge. Travel restraint can only be used on large flat surfaces. There can be no openings to a fall below. The system will not permit a worker to fall, as it is designed to limit the worker's travel to stop them before they reach an edge, which would result to a fall below. A travel restraint system will contain an anchor, body harness, and connector. Limitations. 1. Travel restraint can only be used on flat surfaces with no openings. You cannot apply body weight to a travel restraint system under normal usage. Uses. 2. Flat roofs, on the ground when working beside excavations deeper than 3 meters or 10 feet, when working in a building that has guardrails removed. Types. 3. Travel restraint systems use most of the various types of connectors, such as fall arresters and life safety ropes, horizontal lifelines, and lanyards. There are a variety of configurations of lanyard that can be used. Single leg lanyards, double leg lanyards, lanyards with small snap hook connectors, large snap hook connectors, carabiners, tie-back lanyards, adjustable lanyards. Lanyards can be constructed of wire, rope, and webbing. Read the manufacturer's instructions and make sure you select the most appropriate connector. Generally, self-retracting devices cannot be used for travel restraint as they will allow you to fall off the edge, which would be fall arrest. Compatibility. 4. Ensure the components connect to each other in a safe manner. For example, never connect two snap hooks to one another as they may bind and break the gates of one connector. Fit. 5. According to hierarchy of hazard controls, this is a PPE option, therefore used as a last resort. However, it should be used before a fall arrest system is used. Hazards. 6. Hazards of travel restraint systems are due to improper setup. These include falling off the edge, falling through an opening, and swing falls. Additionally, you could trip on the connecting device. Work positioning systems. Definition, design purpose. A work positioning is a primary body support device that allows you to replace your hold on the structure for support from a positioning system such as a lanyard connected to your waist. Work positioning can increase your level of safety when working with a fall arrest system. Properly set up work positioning will eliminate free fall. In addition to lanyards, descent control devices can be used in work position. They can be used to lower or aid in raising your body in a vertical work environment. Work positioning is a primary fall protection system. Limitations. 1. Travel restrict and work positioning systems can only be used as a primary body support. This means that a backup fall arrest system must be used. Uses. 2. Anytime a worker needs to use their hands or feet for work, or if there are no hand or foot holds to support the body weight. Types. Travel restrict and work positioning systems can be as simple as a short lanyard attached to work positioning rings on the hips. Compatibility. 4. Travel restrict and work positioning systems lanyards must be properly rated before use. If a descent control device is used for positioning, ensure the correct rope diameter is used. Fit. 5. Select the correct length of positioning lanyard to position you properly for the work. This will eliminate ergonomic hazards resulting from poor body positioning. Hazards. 6. Do not allow free fall into a travel restrict or work positioning systems. They do not have energy absorbers built in, and large shock loads will be exerted on your body. 7. Ensure these are used with backup fall arrests at all times. 8. Workers who are inexperienced with travel restrict and work positioning may become confused with the extra lanyards connected to them. This often leads to tangled lines and accidental disconnection. Section 6. Hazard assessment. All jurisdictions require that employers and workers complete a hazard assessment before they begin working. Hazard assessment must look at the work being done and implement the most effective control. Workers using fall protection equipment must also complete a hazard assessment for the work. In some cases, this is contained inside the fall protection plan for the job. When we are completing a hazard assessment for a task, we typically use the following hazard assessment pyramid. Elimination. Eliminating a hazard is the most effective means of controlling it. This involves the physical removal of the hazard. For example, if employees are required to work high above the ground, the hazard can be eliminated by moving the piece they are working on to ground level to eliminate the need to work at heights. Engineering controls. The third most effective means of controlling hazards is engineering controls. Engineering controls do not eliminate hazards, but rather keep people isolated from them. Capital costs of engineering controls tend to be higher than those the less effective controls within the hierarchy. However, they may reduce future costs. For example, building a work platform, or installing guardrails, rather than purchasing, replacing, and maintaining fall arrest equipment. Administrative controls. Administrative controls are changes to the way people work. Examples include procedure changes, fall protection training, and installation of signs and warning labels. Administration controls do not remove hazards. Rather, they limit or prevent people's exposure to them. For instance, by using safety nets below the work area in addition to fall arrest. Another administrative control is the use of a control zone to protect an unguarded edge. Personal protective equipment. Personal protective equipment, known as PPE, is the least effective way to control hazards. PPE includes fall arrest equipment. Using fall arrest equipment, you will still fall. Because you are falling, there is still a potential for you to be injured. PPE is the least effective means of controlling hazards because of the high potential for the PPE to become ineffective due to damage. Additionally, some PPE, such as fall arrest equipment, require increased physiological effort to complete a task and may require medical examinations to ensure the worker can use the PPE without any detrimental risk to his or her own health. Hazard assessment case study. Drilling an oil well requires a worker, aptly named the derrick man, who works halfway up a derrick typically located 60 to 100 feet or 20 to 35 meters off the ground. He experiences significant risk when control of the formation being drilled into was lost. In the event that this occurred, thousands of pounds of pressure would release highly flammable gas, often creating an explosion. The worker's life depended on his ability to escape by using a Geronimo. The Geronimo is essentially a zip line. The Geronimo device was not user-friendly or simple to operate, and for workers who were afraid of heights, it was terrifying. Prior to some notable fatalities between 2000 to 2005, workers were given very little training on the use and inspection of the Geronimo. In some cases, workers were so afraid to use it that they simply jumped out of the tower instead of burning to death. In response, there were several solutions. Workers were given better training on the use and inspection of the Geronimo. A simpler and more reliable escape pod was developed. It is similar to a small elevator. The derrickman's job at height was automated by a hydraulic arm. The derrickman controlled the arm, but it was operated from the ground level. Section 7. Fall Protection System Components. Fall protection systems have three components: anchorages, body harnesses, and connecting devices. Fall protection and rescue plans. Anchors connect us to an appropriately strong part of the structure. This can be achieved by using temporary anchors, such as webbing or cable sling that the worker wraps around the structure, or by developing a permanent anchor, such as a welded-on or bolted-on D-ring. Body harnesses are fabric devices that support the weight of our body before, during, and post-fall. They distribute the forces of a fall safely to our body and keep us upright. Connecting devices attach the body harness to the anchor point. There are several common types, such as lanyards, vertical lifelines, self-retracting devices, and horizontal lifelines. Fall protection and rescue plans are also important. Before we use fall protection equipment, we must have a plan in place to use the equipment safely and ensure an effective rescue if a worker falls. Chapter 1 Review. In Chapter 1, we discussed the fundamental concepts of fall protection. In the following chapters, we will build on what we learned in the first chapter.